Basic needs to sustain human life are clean air, fresh water, nourishing food, and adequate shelter. You can live for a long time without food and shelter, days without drinking water, but only minutes without air. What kind of air did you breathe today? Was it pure and fragrant as a country breeze? Or was it like this? The human body is a magnificent machine. With minimum care, it performs many functions. It's a chemical plant and thinking machine without equal. The nervous system, with complex lines of communication, outperforms the most modern telephone system. The mind of man has enabled him to overcome most deficiencies. It has created machines of great strength and capacity to work for him, and aircraft for fast transportation. For personal use and convenience, man has created the automobile, man and his car. In comfort, he enjoys the pleasure and independence of personal transportation. But the creator of the automobile does not always protect himself from dirty air. He often takes better care of his car than of himself. Here, a demonstration is being given to show what air is and why it is vital to human life. It can be seen in this experiment that some component of the air is being consumed, for the colored water is taking its place. The candle flame flickers, then goes out. The component that was consumed was oxygen. Oxygen is constantly required for body metabolism, the complicated process by which the body burns fuel. The digestive system changes food into a form required by the metabolic process. Oxygen makes up approximately 1/5 of the Earth's atmosphere by volume. For all practical purposes, the remainder is nitrogen. While oxygen itself is not flammable, it does support combustion. Observe what happens when a burning match is lowered into a jar flushed with oxygen. When the burning match is lowered into a container flushed with nitrogen, the flame is extinguished, because nitrogen is an inert gas that does not support combustion. Normal breathing extracts oxygen from the air and expels carbon dioxide. Oxygen-laden air enters through the mouth and nose and moves down the windpipe into the lungs. Blood in the lung tissues absorbs oxygen from air. The heart then pumps the blood through the arteries to provide oxygen to the cells. As the blood returns to the heart, it accumulates carbon dioxide, a waste product of metabolism, and carries it back to the lungs, where it is released into the exhaled air. The brain constantly needs oxygen. When deprived of oxygen for 3 or 4 minutes, brain damage may occur. Unconsciousness results, and after several minutes, the heart stops beating. Normal air contains a little more than 20% oxygen. Atmospheres containing less than 16% are hazardous. This is the minimum that will support normal combustion. The Bureau of Mines recommends that mine atmospheres should contain not less than 19.5% oxygen. Oxygen deficiency can become a hazard in some mines. Atmospheres and some poorly ventilated mines progressively lose oxygen and build up excessive quantities of carbon dioxide, nitrogen, and other contaminants. There are other areas where a potential danger of oxygen deficiency may exist. For example, abandoned mines, caves, or caverns are attractive hazards to people unaware of any danger. Annually, many persons lose their lives when exploring unventilated places. This giant cube represents normal atmosphere. It has a volume of 1 million cubic inches and measures 100 inches on each side. The top two layers of yellow cubes represent the volume of oxygen in normal atmosphere. The greenish-blue remainder is nitrogen and small amounts of other gases. Human lungs have a vital capacity of about 230 cubic inches. At rest, the lungs exchange 25 to 30 cubic inches of air with each breath. The American Conference of Governmental Industrial Hygienists has adopted 5,000 parts per million, or 0.5% of carbon dioxide as the threshold limit for a safe 8-hour exposure. Carbon monoxide is also a contaminant of the air we breathe. It is a silent killer, one that kills more people than any other contaminant gas. Dangerous concentrations of carbon monoxide occur whenever there is incomplete combustion of a carbon, such as coal, wood, gasoline, and other hydrocarbons. Carbon monoxide kills by replacing oxygen, which normally combines with the hemoglobin of the blood. The affinity of hemoglobin for carbon monoxide is about 300 times greater than it is for oxygen. A small amount of carbon monoxide resulting from breathing contaminated air will accumulate in the bloodstream, progressively reducing its vital oxygen-carrying capability. In high concentrations of carbon monoxide, a person may collapse without having noticed any symptoms. Symptoms of carbon monoxide poisoning are similar to those of oxygen deficiency: tightness across the forehead, dilated eye pupils, throbbing temples, weariness, weakness of knees, vomiting, and collapse. Adequate ventilation can prevent the contamination of air in working areas. When a gas which is lighter than air is the contaminant, fresh air should be taken in near the floor and exhausted near the ceiling. Contaminants heavier than air will flow downward. Therefore, ventilation for these gases should have the fresh air intake at ceiling level and exhaust at floor level. Protection against gasoline vapors and petroleum gases depends on care in handling and adequate ventilation. Warning signs and fire extinguishers should be prominent in all hazardous areas as an added precaution. If a contaminated atmosphere must be entered, protection can be obtained by wearing an approved canister-type gas mask, provided the concentration of gas is low and the oxygen content is over 16%. In higher concentrations, an approved air-supplied mask or self-contained breathing apparatus should be used. Hydrogen sulfide is a contaminant gas and may occur in many places, such as in mines, in chemical and metallurgical plants, and in the petroleum industry. It is highly toxic, corrosive, and when combined with iron and exposed to air, sometimes fires spontaneously. It is colorless and tasteless. However, in a concentration of 1 to 100 parts per million, it has a characteristic odor of rotten eggs. Although many persons have been overcome by hydrogen sulfide because they could not smell the gas, the average person can detect from 1 to 100 parts per million. Above this concentration, the sense of smell is paralyzed. 50 parts per million can cause eye irritation. And 1,000 parts per million will cause death within a few minutes. Detectors for hydrogen sulfide are available and should be used when there is any possibility of encountering this highly toxic gas. Sulfur dioxide is another irritant gas. It is formed by burning sulfur or by heating sulfurous ores and compounds. It's approximately twice as heavy as air. 5 to 20 parts per million causes irritation of the throat and eyes. 500 parts per million is intolerable. Authorities suggest a threshold limit value of only 5 parts per million. Many other contaminants are generated as the byproduct of normal industrial operations. Fumes, mists, and particulate matter result from vaporization of metals, often associated with oxidation. The more common toxic fumes result from lead, zinc, and cadmium operations. Fume particles range in size from 1/1000th of a micron to 1 micron and are readily airborne. Most fumes are irritating and can cause illness. In fact, fumes from lead and zinc are highly poisonous and can cripple or cause death. The hazards of silica or sand inhalation by workers have been known for many years. Where exposures are recognized, control measures and protective devices are usually used. When silica particles are inhaled, they may reach the lungs where, if they are retained, the cumulative effect progressively reduces lung efficiency and ultimately incapacitates the individual. Dust inhalation can be serious. Pneumoconiosis is a general term covering diseases of the lungs caused by inhaling dust. Dust particles may be silica, sand, or mineral dusts. Pneumoconiosis also refers to coal dust accumulation in the lungs of coal miners. This disease is based upon the reduced lung efficiency of workers exposed to anthracite or bituminous coal dust. Iron ore workers are exposed to metallic dust, which can accumulate in the lungs. Siderosis is the term applied to lung impairment caused by this accumulation. The size of dust particles is important with regard to both hazards and retention in the lungs. They are measured in microns, which is a unit of length equal to 1/25,000th of an inch. The most dangerous dusts are those below 5 microns in size. These minute particles can remain in suspension in the air for long periods of time. It is generally believed that particles larger than 5 microns are filtered out in the nose and throat before reaching the lungs. The dusts and gases we have mentioned are but a few of the many that may be encountered in our industrial complex. Protection against these contaminant gases and dusts can be accomplished through the use of protective equipment, good housekeeping, directed ventilation. Heavy gases should be exhausted from low areas, light gases from ceiling areas. Understanding the hazard and following all instructions and warning signs. The human body is the most remarkable machine on Earth. When taken care of, it will outlast most mechanical devices. However, we must all learn to protect ourselves and preserve the most precious gift of all, our lives. This can be done only with the help of nature's bountiful gift, the air you breathe.